Good morning, everyone. Hope you are good. Welcome back once again. Welcome back to this channel. So, as we all know that we have started this beautiful journey towards calculus from part one. So, this is going to be the part three of that series. Okay. So, we have another beautiful concept today. That is what using chain rule. Where can we use chain rule? How can we use it? Like, how do we implement chain rule? What is even chain rule? So, anytime we have composite function, what we call composite function, we can also call it function of a function. That is when we will use chain rule. Then, what kind of function do we call function of a function or composite function? Everybody, let's say, for example, let's say we have let y to be equal to f of u. This is a function of u. Everything we have been doing before, that time that we say y is equal to 2x, find the y dx. Here, y is a function, f, that's a function of x. Are you getting it now? But let's say, for example, we now have y to be f of u, and u is now what? U is now, let's say, another function. Let me call it g. So don't let me use f again, but this one also is a function, g of x. Look at this one very well. Y is f of u, function of x. U also is a function of x, but we are just using g here. In that situation, in that case, I can say that that is y is, I cannot say y is f of what? U. And what is u? G of x. It should now be f of g of x. Close bracket. Anytime you have something like this, then what is dy dx? We now say dy over dx. When you have y to be function of u, and you have that same u to be function of x, dy dx, differentiate y with respect to x will now become dy du. You will first of all differentiate y with respect to u, multiply by du dx. You differentiate u with respect to x. Very beautiful. This is what we call chain rule, and we use chain rule whenever we have composite function. Composite function means a function of a function. That is, for example, u is one function of x, but y is now function of u. That is a function of a function. Do we get that? Okay. Now, let us now go through all these beautiful examples. And don't forget, as usual, we are going to do 1 to 3 together, and this number 4, you understand. As usual, right? That's a very beautiful gift from me to you, okay? So this number 4 is for all of you, okay? Good. Now let's start, everybody. Solution to that example. Look at that example now. So we have 1. Y is what? Y is 3x plus 5. Can you see? Raised to power 6. Now, in this case now, this one is not like the way we have been having our functions before. Maybe y is 2x raised to power 5, y is 3x squared, all those things. This one is one function inside. Can you see? This one inside the bracket is one function on its own. Of course, it's a function of x. In order to make, of course, we can do it directly. There are ways that we can use a very simple way to do it directly as a shortcut. But in order to break everything down, especially if you are being given this kind of question in theory, the best approach that you will give to it, I will show you now. That's what we are going to use. If it is an objective, I will show you that one as well later. Now, let's say, for example, now we have this, and we have to find the y dx. We now introduce, for our own convenience, to make everything easier for us. We now make an assumption. Let u, somebody will be like, why are we using u? Is it necessary for me to, is it a must for me to use u? No. I can use something else instead of u. I can even say v. It will now be f of v. So v will now be g of x. So it will now be dy du, dy dv times dv dx. I can also use that as well. So we are just using u as just an arbitrary what? Variable. So let u to be what? 3x plus 5. That is the one inside the bracket. Am I communicating? Good. If u is this, then what will be y? y will now become 3x plus 5 is now u. You now say y will now become u raised to power what? 6. Don't forget, we said let u to be 3x plus 5. Since u is 3x plus 5, you now come back here and substitute u for 3x plus 5. Wherever you see 3x plus 5, put u there. Y will now be u raised to power 6. Wow, that's very beautiful. Now I can now say that, okay, therefore from here, let's say this one is equation 1. Let me say this is equation 2. So from equation 1, I can get the u. I want to differentiate u with respect to x because this is a function of x. Du dx as what? Differentiate 3x. You remember the last one we did in part 2. That is derivative of a sum or difference. Can you see 3x plus 5? Right? Differentiate 3x. As usual, it will be what? 3. That means 3 x raised to power 1 minus 1. That's x raised to power 0. That's 1. Abi? 1 times 3, isn't it? Do you get it? Then plus what? Plus 0. Because when you differentiate constant, 5 is constant. It will give us what? 0. And the answer is what? 3. Comma. Then from equation 2. From equation what? 2. What is in equation 2? We have y, let me write it down, y u raised to power 6. Then dy du. What is dy du? It will now become, what is coefficient? 1. Then 6, that power, 6 times 1, that's 6, u raised to power of 6 minus 1, that is 5. Now, everybody, we have gotten dy du dx, dy du. But do you know what's funny? Nobody asked us to find dy du now. We are interested in finding dy dx, but for our own convenience, we introduce another variable to make the whole thing easier for us. Now, what do? We now come and use this formula, this chain rule. We now say that, can you see, you remember that whenever we have something like that, what is dy dx? Dy dx now say, therefore, dy dx will now be dy du times du dx. Now say dy dx is equal to dy du times du dx. You remember, that is our chain rule, isn't it? Now, what do we now do? We now substitute. So dy dx will now become 6u raised to power what? 5 multiplied by what? What is du dx, everybody? That's 3, isn't it? 3. And that's going to be 3 times 6. 18u raised to power 5. But we are not concerned about u raised to power 5. Nothing concerns us about u. We are interested in x. You will now say that since this is dy dx, mind you. Since what is u? Everybody, what is u? We now say since u is 3x plus 5 from here. Substitute. Now say therefore dy dx is equal to what? 18 u. What is u? 3x plus 5 raised to power of what? 5. Wow, that is beautiful. Do we understand? Perfect. So it's as beautiful as that, okay? Let's go for number 2 now. Number 2. Now everybody, let's go. Number 2 is what? Number 2 say that if y is what? Px plus q raised to power n. Can you see? This one inside the bracket as well is a function of x. Don't forget, this q will be a constant, mind you. We have to find dy dx. The same thing as usual. We just say that let u to be the one inside the bracket, px plus q. Wow, beautiful. Then I can even do it directly from here, okay? So I can say, since u is px plus q, okay, what is du dx? I can get it directly so that it will be easier for us like that. Du dx is differentiate px with respect to that's p, then plus q is a constant, so it will be 0, okay? So that means du dx is equal to p, comma. Then also, what is y? Y will become, ps plus q raised to power n. And what is ps plus q? U. So y will now become u raised to power of n. Then what is dy du? Dy du will now become, what is coefficient? 1 times power n, that is n, right? Then u raised to power what? Power minus 1, n minus 1. That's our formula, isn't it? Beautiful. I will now say that. Okay, now dy dx will become dy du times what? Times du dx. Wow, that is beautiful. That's lovely. We now make the substitution, everybody. And what is the substitution? We just say, okay, therefore, dy dx is what? What is dy du? This. N u raised to power n minus 1 multiplied by, what is du dx, everybody? That's p times p. This one will now become n p u raised to power n minus 1. Beautiful. But what? Since what? Since what is u? Since u is px plus q, comma, therefore, you just substitute, that is, wherever you see u, just come and replace it with this guy, because that's what we, that's our assumption from the initial stage. We now say, therefore, the y dx will now become what? N p, okay, into bracket. What is u? U is this. Just replace it. Very simple. Px plus q raised to power what? N minus 1. N minus 1. Wow, that's lovely. Beautiful. That is our dy dx. Can you see how beautiful it is, everyone? Yeah, that's lovely. Finally, number 3. Number 3. So, what do we have, everyone? We have to find number 3. What do we have? Y is what? 1 divided by 3 plus x squared. Don't forget square root, okay? Wow, this is cool. What do I need to do? I can say let what? Let u to be the one inside the square root, okay? That is the easiest way. The one inside the square root. Or better still, let me show you something, everyone. Let me show you something. Let me show you another very beautiful approach. You know, I have many ways to do this kind of thing, but let me give us a very simple approach. You remember what I normally tell us, that make sure you simplify this thing first. Rewrite it as power of something. So this one, I can write it as simplify first. Don't just jump to y is something, okay? So simplify. Don't jump into the y dx is equal to something or u is equal to something. Let us simplify first. I can write this one as 1 divided by 3 plus x squared raised to power half. Why? Square root. You remember from the law of indices, square root, we can use square root. We can write square root as this thing raised to power 1 over 2. Am I communicating? So now I can also say this is y is equal to what? Everything like this. Because I have a reciprocal 1 over this. From that law of indices, I can say this is 3 plus x squared. Are you with me? Raised to power 1 over 2. Everything raised to power what? Minus 1. Why? Because of this 1, okay? Then y is equal to what? 3 plus x squared, okay? Raised to power what? 1 over 2. Because this power half, this power minus 1. They can multiply each other. Minus 1 times half, that's raised to power minus 1 over 2. Beautiful. Now, it is very easy for me now. I cannot say, okay, from here, let u to be what? 3 plus x squared. Wow, this is lovely. Then from here, what is du ds? Du ds will be, this 3 is a constant, that's 0, plus differentiate x squared. Coefficient of x squared is 1. Oh yeah, power is 2. 2 times what? This, that's 2. X raised to power 2 minus 1. That's 1, but you don't need to put 1 there. That is okay. So du ds will give us what? 2x. Beautiful. Now, next thing is what? Since what? Since u is 3 plus x squared, I come back to this one. You now say, also, what is y? Y is what? 3 plus x squared, and that is what? U. We have already said that we have made an assumption that let u to be that. That be what? U, then raised by what? Minus 1 over 2. Okay? Now from here, we want to find the y du. dy over du. And that is what? Multiply the power by coefficient 1. That's minus 1 over 2. So minus 1 over 2 times 1 minus 1 over 2. The u raised by what? Minus 1 over 2 minus 1. You know, the power minus 1. Okay? This over 1 as usual. So what would that be? This like minus 3 over 2. If you find the LCM, you know we have done that in indices as well. You find the LCM 2. 2 in 2. That's what? 1. 1 times this, that's minus 1. Minus 1. 1 from 2. 2 times minus 1, that's minus 2. So minus 1 minus 2, that's minus 3 all over 2. Can you see that? Very simple as that. So what do? You now say this is going to be minus 1 over 2, u raised to power minus 3 all over 2. Wow, very beautiful. Okay. So I can even say that This is what? Minus 1 over 2, because of this minus raised to power minus, multiplied by 1 over u raised to power 3 over 2. I can write it as that. Is that not true? So this is going to be what? Minus 1 times 1. Numerator, that's minus 1. Divided by 2 times it, that's 2 u raised to power what? 3 all over 2. Okay, this is our dy. The what? Oh, this is dy du. Sorry, this is dy du. Dy the what? Du, because y is a function of u here. So our dy du is equal to this. Okay. Now, if dy du is this, so dy du is minus 1 all over what? 2 u raised to power 3 all over 2. Are you with me? That is our what? That is our dy du. But we are interested in dy dx, everybody. Okay? But don't forget, we now come and use our what? Chain rule. Don't forget, what do we get for du dx? We got 2x. Okay? Don't forget, so we got 2x because we are coming there. So I will now say that, okay? So we got du dx to be 2x. Okay, this is our du dx. That's what we obtain, 2x, right? So we now continue from here. We now say, since du the what? dy du is equal to this. Dy du is equal to this. Du dx is equal to this. We now say, then dy dx is equal to dy du, our chain rule, right? Multiplied by du dx. Wow, that's lovely. This one will now become what? It will now become, what is this? Minus 1 all over 2 u raised to power 3 all over 2 multiplied by what? What is du dx? 2x. Beautiful. 2x. That's lovely. 2 here, we cancel 2 here. That's good. This is now going to be minus 1 times x minus x divided by u raised to power 3 all over 2. Wow, that's good. Are you with me, everyone? Perfect. So this will now become minus x divided by, what is u? Don't forget, we said that u should be what? We said u should be equal to 3 plus x squared. You now replace it as what? You now say since, okay, don't worry, let me say since what? Since u is 3 plus x squared, I will now say dy dx is now equal to, that is, don't forget, this is our dy dx, minus x divided by, what is u? This one, 3 plus x squared raised to power what? 3 all over 2. Wow, that's lovely. Do you know that I can even simplify this one further? I can say this is the same thing as what?
And I say this is equal to what? Minus x divided by, can you see this? We have this one raised by 3 all over 2. So this 2 that we have here as the denominator, we now make it to become square root. But you remember that law of indices, you don't need to put that 2 here. So once you say square root, so it means that we have taken care of this one. Then 3 plus x squared, this one 3 plus x squared, then raised to power of 3. Wow, that's lovely. Can we all see that? That's good. So don't forget your very beautiful gift. Make sure you do it, okay? That's very good. And don't forget, everyone, kindly subscribe, share, and like. Take care. So we meet in the next video. Bye.